All right, so I had several people ask about the homework that we had tonight, and I want to review some of the things we talked about in class first, and then we'll talk about a few of the examples from the homework to see if we can make it make a little more sense here. So remember from class, we said a few things. We said if you have an isosceles triangle, so that's a triangle where at least two sides are congruent, then the angles across from those sides, so you got this side right here, the angle across from him is congruent to the angle across from this side over here. That is known as the Isosceles Triangle Theorem here. All right, and then the converse is also true. So if you've got some isosceles triangle, actually we don't, let's suppose we don't know it's isosceles, but we know that two angles on this thing are congruent. So since the two angles are congruent, the sides across from them must be congruent as well. This also works for equilateral triangles, which is a special case of isosceles. We've got more than two sides congruent on equilateral. We got all three congruent, so we know all three angles are going to be congruent as well. Same thing with the converse over here. If you know all three angles are congruent, then you know the three sides across from those angles are going to be congruent. The other thing we discussed had to deal with isosceles triangles, and we said that if you have two sides that are congruent and you draw a line through the vertex and that bisects that angle, then it means that it's going to be meeting at a perpendicular to the base side, and it's going to be dividing that side in half. The converse is also true. If you've got an isosceles triangle and you know that you're cutting that side in half, then this must be a right angle, and those two angles right there must be congruent. It's bisecting that angle. And I should note that not only are you cutting it in half, but this line right here is going through the vertex of that isosceles triangle. Now, our homework says, we'll start, and what I'm going to do with the homework is I'm not going to answer them all. You know, it's your homework, but if this helps you out, I'm going to answer a few of these. So let's pick, I don't know, a random one here, number 2. So number 2 says angle BED is congruent to what? So if we look over here, I'm just going to highlight BED. It's this angle right here. So we want to know what angle is it congruent to. Well, notice that triangle BED, and if it helps you redraw this thing, triangle BED is isosceles. I'll show you the angle the triangle I'm redrawing there. So angle BED, that's this angle. What angle is it congruent to? It must be congruent to this one right here. But I can't just say angle D because there's too many angle D's up in the actual diagram. I've got to say angle BDE. BDE. That would be this angle right here. Why is it congruent to this angle right here? Because these two sides are congruent. So by the isosceles triangle theorem, I know that BED must be congruent to angle BDE. And we can do the same with the others here. If we've got AB, what is it congruent to? AB's, we'll do number 4 also while we're at it. I'll just clear the drawings on here. So for number 4 says AB is congruent to what? AB is right here. We also know, well, it's saying that it's going to be congruent to something which is congruent to BE. BE is right here. Notice this triangle I'm tracing out right here. It has all three angles congruent. So if all three angles in a triangle are congruent, all three sides must be congruent. So BE is congruent to AB. It's also congruent to the one not listed on that statement, which is AE. I'm going to pick some random numbers here. I'm going to go with 8 and 7. Let's do those. So number 7, once again, we've got, well, I might pick a different. This is kind of easy. I'll just tell you how to do it. This is an equilateral triangle. How do I know that? Because all three sides are congruent. If all three sides are congruent, all three angles must be congruent. And if you don't have it memorized yet, if I know all three angles in a triangle are congruent, let me call them all x. I suppose you don't remember what the measure of all three are. So if all three angles are congruent, then I know that all three add up to 180. So x plus x plus x equals 180. And then the rest is just solving for x using algebra. We get 3x equals 180, or x is equal to 60. So I know that in every equilateral triangle out there, it's also equiangular, and they all equal 60. So for this one, you say x plus 5 equals 60, or x equals 55. You're going to do the same thing for this one. Set y minus 10 equals 60 and solve for y. Let's look at number 6. Number 6 is a little bit trickier. So number 6 I know is isosceles. This exterior angle is 135. Remember, this is a linear pair. So how do we handle linear pairs? You're going to say, well, 135 and this angle right here, whatever it is, let's call it z, must equal 180. So z plus 135 equals 180. Subtract 135 from both sides, you get 45 is equal to z. Now, looking at our angle up here, let's see, look at what type of triangle we have. We have an isosceles triangle. How do I know that? Because this side is congruent to this side. That means this angle must be congruent to this angle. Well, we just figured out x, because this angle right here must be 45, so this one's 45. I'm going to redraw that triangle down here. I've got 45-degree angle, 45-degree angle. What must the top angle be? Add these two right here up and subtract it from 180. You get this angle to be 90. So y in this case is 90 degrees. This one down here on the left, you've got 3y and 2x. We know that they're congruent because these two sides are congruent, but notice all three sides are congruent, so this is an equilateral triangle. You're going to solve that one just like you did number 7. I'm not going to do that one for you. You can figure that one out. Number 5 is going to be solved in a similar manner as number 6. Number 9, remember this is following that last rule I talked about in the beginning. This one right here. So number 9, I know that since this is meeting at a right angle and it goes through the vertex of an isosceles triangle, that it must be bisecting it. So this must be y as well. So we can look at this angle. If we were to redraw the big triangle there without the center line, I know that this angle is 2y, this angle is x. Because it's isosceles, this angle right here is going to be x as well. Use this information and what you know about linear pairs to solve for x. And then use what you know about the sums of all the angles in a triangle to solve for x. Well, not solve for x, but just solve for y there. Let's look at number 11. It says, find the measure of angle ACB. ACB is this angle. Well, we know this is isosceles, so since this angle is 45, this angle must be 45. These are a linear pair, so this angle must be 45, we'll call it z. 45 plus z equals 180. So z must equal 135. For this one up here, remember that vertical angles are congruent. For number 13, that is. Vertical angles are congruent. You know that since it's an isosceles triangle, triangle DCE, this must be 55. Solve for this angle right here. That's going to be equal to this angle. And then since this is isosceles, we can call this y, and you can say y plus the measure of angle ACB must equal 180, because all three angles of a triangle add up to 180. Okay? And don't forget to do this one. I'm not going to do all of them for you or give you hints on all of them. This is just to kind of get your thoughts flowing on how to do this homework assignment. Number 15, let's see, it says use the diagram for the exercises to complete each congruency statement. Explain why it's true. What is DF congruent to? DF is this side right here. And it's part of triangle DFB. So if you look at this triangle, we know that the base angles are congruent. So the side across from this angle is DF. The side across from this angle, since these two angles right here are congruent, the two sides across from them must be congruent. So that must be DB. And I think you can figure out 16 and 17 from that. This says the wall at the front entrance to the Rock and Roll Hall of Fame in Cleveland, Ohio is an isosceles triangle. The triangle has a vertex angle of 102. Remember, the vertex angle is the angle up here. 102 is that angle. What is the measure of the base angles? So call this x, they must be both x or both equal because they're across from congruent sides. And then set up your equation, x plus 102 must equal 180 because all three angles in a triangle add to 180. Let's just do a couple of these. I'll give you some hints. For number 21, it says find the values of m and n. Well, notice that if this is a 60-degree angle, let's redraw this triangle right here. If that's a 60-degree angle, and these two sides are congruent, then these two sides must be congruent. I mean, these two angles must be congruent. So x plus 60 equals 180. You're going to find out, hey, this is an equilateral triangle. They're both 60 down at the bottom. So I know right here that m plus n must equal 60. Now, I'm going to back this up. Let's actually just clear these drawings. So let's put that thought up here. M plus n must equal 60. I'm just going to have that in the back of my mind. Now look at the other triangle. The other triangle says, let's see, we've got a 45, 45, 90. So if you highlight that triangle, I know that this is 90. Here, let me redraw it. I know if this is 45, this is 90, and these two sides are congruent, well, across from this side is 45. The across from this side must also be 45. So m is 45. Well, I know that m plus n equals 60. So if this is 45 plus n equals 60, n must equal 15. So if you don't know where to start with these, just start by filling out as much information as you can. For number 22, I know that since I've got an isosceles triangle down here on the bottom, that the base angles must be congruent. Then I know that this angle right here, if I add up 68 plus whatever this angle is, I'll call it x, that must equal 180. 68 and 68 give you 136. And subtracting 136 from both sides gives you 44 for x. So this is 44. M is vertical to it, so that must be 44. And notice these base angles up here are congruent because they're both labeled n. So I know that n plus 44 must equal 180. And we're going to find out that they're both equal to 68 then. Since they both have the same vertex angle, the base angles must be the same. I don't want to do number 23 all the way for you because I feel like you can figure these out. But notice you've got an isosceles triangle up at the top. So this angle must be congruent to either m or n. I'll let you decide which one it should be. Notice you have an isosceles triangle right here. So you should be able to figure out these two angles. Just call them both x. You've got 15 right there, and say x plus x equals 15. You can figure out this angle of this isosceles triangle in the middle by saying, you know, this whole angle right here is 90. Subtract 15 from it gives you the base angle. The base angle is right here. Well, I know I went through that kind of quickly. I didn't want to take up too much of your time, but hopefully that gives you an idea of where to get started on the homework. If you have more questions, it's not a big deal. Just ask me tomorrow in class, and I'll be more than happy to help you. Thanks for watching.